So today we are going to majorly focus on the factor formula, and we shall see the derivation part of it, and as well how we use the factor formula to solve certain trigonometrical equations. So did you grasp some of those formulas? Like cos of P plus cos of Q. What is that equal to? You don't remember?
No.
So this one is 2 cos of P plus Q, then we divide it by 2, then cos of P minus Q divided by 2. Then we have the cos of P minus cos of Q, and this one is negative 2. Negative 2 sine, so negative 2 sine of P plus Q divided by 2, then sine of P minus Q divided by 2. So those are the ones for cos. Then we have the ones of sine. So we have sine of P plus sine of Q. This one is 2 sine of P plus Q. We divide this by 2, and then cos of P minus Q. Still this divided by 2. Then we also get the one of sine of P minus sine of Q. And this one gives us 2. Now it will begin with cos P plus Q over 2. Then sine of P minus Q divided by 2. So those are majorly the four formulas that we use, but let us look at the derivation. So we are going to start with the ones of cos. So cos of A plus B. So do you remember what this one is when we expand it? What do we get when we expand cos of A plus B? Joel, what do we get when we expand cos of A plus B?
Yes, teacher. We get cos A, cos
Yeah.
B, minus sin A, sin B.
Okay. Then cos of A minus B. Will just be the opposite here. We just change the sign. So this becomes cos of A, cos of B. Then we add sin A, sin of B. So here we are going to get when we add the 2 and when we subtract the 2. So when we add cos of A plus B plus cos of A minus B, so what shall we have when we do the addition? What do we get when we add those two? Are we trying to do the addition? So when we add the two, we shall get cos of A, cos of B, minus sin A, sin B. Then we add the second one, cos of A, cos of B, then plus sin A, sin B. So we note that this and this will cancel out. So we shall remain with cos of A cos of B plus cos of A cos of B, which gives us 2 cos A cos of B. So that is equal to cos of A plus B, then plus cos of A minus B. Now we are going to let, just a moment. So we are going to let A plus B be equal to P, and the A minus B be equal to Q. So remember, in our formulas, at first the one we stated here, we have where we have P plus Q and then P minus Q. So we are going to create that. So we are going to get P plus Q and then P minus Q. So P plus Q, in order for us to have them here, because after substituting for P here and Q here, they need to as well go this other side. So P plus Q is going to be A plus B plus A minus B. So the B is positive, here it is negative, so we shall remain with P plus Q, giving us 2 what? 2A. So to remain with 2A, with A, we are going to divide by 2 both sides, such that we are going to have A is equal to P plus Q. We divide this by 2. So still we are going to get P minus Q. So this will be the same as A plus B minus A minus B. So when we open brackets, this B will be positive, A here will be negative, so it's going to cancel out with this. So B will be positive, so this will give us 2B, which is equal to P minus Q. So on dividing both sides by 2, our B is going to be P minus Q. Then we divide this by 2. Any questions before we proceed?
Okay, you can proceed.
Okay. So we are going to now get into our equation. So where there is cos of A plus B, so here we are going to put a P. Here we put a Q. Then where there is A, we are going to put P plus Q over 2. And where there is a B, we are going to put P minus Q over 2. And that will give us cos of P plus cos of Q. This is 2 cos of P plus Q divided by 2. Then cos of P minus Q divided by 2. So this will become our first identity in a factor formula. Then after that, we can as well now look at cos of A plus B minus cos of A minus B. So we said this is going to be cos of A, cos of B minus 2 minus sine
Minus
A sine of B. Then we are going to subtract now cos A, cos B plus sine A, sine of B. So what happens when we open brackets? What will happen?
cos will go out.
Cos will go out, okay?
It will go out, yes.
So we are saying on opening brackets, this and this will move out. So this negative will affect this, so it becomes also a negative. So we get negative sine A sine B, and add it to another negative sine A sine B. And then we are going to get negative 2 sine of A, sine of what?
Sine.
Of B. So we substitute with our P and what? And Q. So this will be cos of P minus cos of Q. And this will be equal to negative 2 sine, what was our A?
Or it wasn't it?
What was A in terms of P and Q?
P plus Q out of 2.
Okay.
P plus Q out of 2, then sine P minus Q divided by 2. Okay. Then we can now go to the ones of sine. So we shall still get sine of A plus B. Then we add sine of A minus B. What do we get when we expand sine of A plus B?
Okay. Cos A.
We get
Cos S. Forget cos A sine B.
mm,
And then plus
yes.
cos plus cos B.
Mm. Sine A. Okay, so sine A cos B plus cos A sine B. Then this we are adding it to the same thing when we have changed the sign. So sine A cos B minus cos A sine of B. So which one moves away? Which one is going to move away to reverse a 0? So when we add these two, which one is moving away? Which term is moving away?
The cos term, the cos A and the cos A, the cos A and the sin B are moving out.
So this is positive, this is negative, so that gives us a 0. So we remain with sine A cos B plus sine A cos B, which gives us 2 sine A cos of B. Then we substitute, so this would be sine of P plus sine of Q, and this is equal to 2 sine, what is A in terms of P and Q?
A is P plus Q over 2.
P plus Q over 2. And then cos P minus Q, still that divided by 2. So that is our fourth. Then also look at sine of A plus B minus sine of A minus B. So what would that give us?
It would give us sine A cos B, then plus sine A cos B, then plus cos A sine B.
Then we subtract sine A cos B minus cos A sine of B. So which term is disappearing?
The sine A cos B will disappear.
The sine A cos
Cos
B.
B.
Yes.
Yes.
So on opening brackets, this will cancel out with that to give us a 0. Then we remain with cos A sine B plus this will change this sign to positive. So it becomes plus cos A sine B. So that in the end will give us 2 cos A sine of B. And then we substitute with our P. So sine of P plus sine of Q. This is equal to 2 cos P plus Q over 2. Then sine P minus Q divided by 2. And it becomes the fourth one. All of us okay up to that point? So we can proceed.
Teacher, you can proceed.
Okay. So we are now going to begin using our factor formulas to solve. So we are going to solve the first part, solve the equation. Sine of 3x plus sine x is equal to 0. So for theta between -180 to 180 degrees. So who can guide us on what we are going to do?
So we first have to combine them together.
Using
We combine them, we get whereby we get sine,
yes,
sine, then open brackets 3x plus x.
yes,
Then we write down that formula for sine p plus q.
okay.
Yeah.
Sine, what is
So,
sine
and
p plus sine q?
whereby sine p plus sine q, it is sine p plus q over, it is 2 at the beginning, 2
Yes.
sine p plus q over 2, then cos p minus q over 2.
So we are going to say now sine of 3x plus sine x going to be equal to 2 sine 3x plus x. We divide this by 2, then we get cos 3x minus x. We divide this by 2. But remember, the whole equation is equal to 0. Is that okay?
Yes.
So that is going to give us 2 sine of 4x divided by 2 cos of 2x divided by 2, and this is equal to 0. What is 4x divided by 2?
It's 2 sine 2x.
2x. Then cos x is equal to 0. Which step do we add here?
We put brackets and we put each one to 0. Each term according to 0. Yes.
So we can as well first divide by 2 to give us sine 2x cos x, and this will give us a what? 0. Then from there we can say either sine of 2x is equal to 0, and then we take the sine inverse. So 2x is equal to sine inverse of 0. What is sine inverse of 0?
Is 0.
0 degrees. Then angle in the, okay, let us take this to the second page. So 2x is equal to 0. So what we are going to do, we are going to draw our quadrant. So we are going to draw our quadrant. Then so we need to mark where we get the positive angles and where we get the negative angles. So this would be 0 degrees. This would be 90 degrees. This would be 180 degrees, 270. And then when we get back here, it gives us 360. Now, for positive angles, we move in that direction. Then for negative angles, we move in the clockwise direction. Okay. So let us begin with the positive ones. We are saying 2x is equal to 0 degrees. And then the second one would be, so when we move in this direction, what would be our second angle? Where sign is positive?
Where sign is positive.
Yes.
180.
180. Okay. So remember, we are still continuing. So since we have a 2x, we are going to move twice. Okay, 2 times, such that after dividing by 2, we get angles that fall in our range of positive 80, 180 and negative 180. So if we have moved here, so we are going to get back to here. So our other angle is going to be 360. Is that okay? Now, after dividing by 2, the 360 would give us the 180. So there is no need for us to do what? To continue. Is that okay?
So, but teacher, if we had continued, now what we're going to get?
So if we continued to here, we would get 360 plus 90. What would that give us?
450.
460.
450. 450.
450. Then to continue here, we again add the 90, and this would give us
50 plus 90. 540.
540.
540.
540 plus another 90.
630.
And when we get back here, it would be 2 what? 270. So that is how you deal with it if this is what? Is a 2x or if it is a 3x. So if it is a 2x, you go 2 times. If it is a 3x, you go 3 times, because after you're going to divide by the 3 to remain with the angle x.
So
okay.
Can you be asked for x?
Yeah, it depends. Something can come up. What is most important is for you to know the idea of what you need to know when it is a 2x, when it is a 3x, when it is a 4 what? A 4x. You need to move around the circle 4 times. Okay? Yes, so when we take this direction, we would still have 0 degrees, which we don't need to write again. Then when we get here in the anti-clockwise, it would be negative 180. And getting back here, it would be negative 3 what? 360. And then now we divide by 2 for these angles. For all of them, we divide by what? By 2. And then we write our x is going to be, so it is better we begin with the negative angles. So we shall have negative 90 degrees, negative 180 degrees, then 0 degrees, 90 degrees, and 180. Is that okay to all of us?
Yes.
Then we
But,
got, yes.
I expected you to begin with negative 108 because
That is okay. It's greater than the 90, is less than the 90.
It's less than the negative 90.
That one is okay, it's okay there. Negative 90, then 0, and 90 degrees, and 180. So after that, we go to the either part where we have cos x equaling to 0. So remember it was here. So cos x equaling to what? To 0. So this would give us, so x would be cos inverse of 0. And what is the cos inverse of 0?
Which is 90 degrees.
90 degrees. So where else is cos negative? No, cos positive, positive.
In the fourth quadrant.
In the fourth quadrant. So where we get 360 minus the angle. So 360 minus 90.
That is 270.
That is 270. Then on the negative, when we have taken this direction, we shall have 90 degrees, negative 90,
Negative 90 degrees.
and then negative 2.
Negative 270.
But we only need angles in the range of negative 180 to 180. So what would x be equal to?
X would be equal to negative 90 degrees, then 90 degrees, and then negative 90 degrees, and then 90 degrees.
90 degrees. And then later we can write the solution set for the whole complete. So we write these angles and then plus these ones. Okay. So the 90s are already here, so we might not need to write them double. So I can say is 180, negative 180, negative 90, 0 degrees, 90 degrees, and 180 degrees. Is that okay?
Yes.
So we can go to our next question if there are no questions. So our next one, we are going to solve for cos of x plus 20 degrees minus cos x plus 80 degrees equaling to 0.5. So how are we going to go about that?
Teacher, we shall pass this the
Yes.
we shall first list the formula of cos minus cos, which is
Cos P
negative 2
minus cos Q
cos q,
negative 2
negative 2 sine p plus q over 2, then sine p minus q over 2.
Okay. So we are going to apply this and we say cos of x plus 20 degrees minus cos x plus 80 degrees. So this is going to give us negative 2 sine. So we have x plus 20 then plus x plus 80. We divide this by 2. Then also have sine of x plus 20 minus x plus 80. So this is 0.5 is equal to this. Okay, yeah, it is also supposed to be divisible by 2. So x plus x gives us
X plus x gives us to x.
x 20 plus 80.
20 plus 80, that is 100.
Then we divide this by 2. Then multiply by sine. Sine
Multiply by sine by to be eliminated. Then multiply by sine.
are you sure cos of p plus q is negative? It is cos of p minus.
Minus, yes.
Cos of p minus. Okay, yes. So here we shall have x minus x, that gives us a 0. Okay.
Yes.
Then 20 minus 80 is a negative.
Negative 60.
Divide by 2.
Divide.
So 0.5 is equal to negative 2 sine of x plus 50 degrees, and then sine of negative 30 degrees. What is sine of negative 30 equal to?
Sine of negative 30 is equal to negative 0.5.
Negative 0.5. Okay, so we can write it as sine of x plus 50 times negative sine 30. So those are the same. Then we say this a negative and negative will give us positive, so it will be 2 sine of x plus 50. Then we multiply by this. You say this is a half, huh?
Yes, negative 0.5.
Okay. So 0, we can call it a half here. Then this will cancel out with the 2. So we remain with sine of x plus 50 degrees, giving us 0.5. Yes.
Teacher, first a little bit here on 0.5. Then how comes that a half? I thought it is supposed to be a negative a half.
No, this negative and this negative became positive. Negative times negative. So I wrote it here as a positive.
Then this one became a multiplication sign.
Yeah, it is a multiplication. Sign this, sign this. So here in between them is a multiplication sign.
Okay, teacher, I get you. Teacher, can proceed.
Okay. So we have sine of x plus 50 degrees, giving us 0.5. So what are we doing next?
Expand it.
We expand.
Sure.
Helen, what do we do next? So when we get here, we just take the sine inverse both sides. So x plus 50 degrees will be sine inverse of 0.5. What is sine inverse of 0.5?
Sine inverse of 0.5. Sine inverse of 30 degrees.
And 30 degrees. So we are going to get the other angles. So sine is positive, so positive this, then we shall as well have in the second quadrant, which is 180 minus 30. So that would give us 150. So remember, we have both positive and what? Negative. So here we shall have negative 30, and then as well a negative 150. So then we add the 50 on the both sides. So
there we are getting negative 20. No. It becomes a positive when a negative when it goes down.
So we shall have negative 100 when we get the 150 plus 50.
No, teacher. I thought that when this
it becomes a negative. Okay.
So
sorry about that.
We get negative 200 degrees.
Negative 200, that is outside the range. Okay.
Yes. Then 50, negative 50, 30. We get negative 80.
Negative 80. Then 30 minus 50.
That's 20. That's negative 20 also. Then 50. That's 100 degrees.
I hope we have not left out any other angles. Okay, so this would be a possible solution to our question.
Yes.
Okay, so because of time, we are stopping here. So I'm going to possibly send you to back house to look for some work to do there, and then you send your work for marking about the factor formula. Yes.